of all administrative fees that I earn for being a multimedia in-class instructor. Colette, saving the bacon again. All right, interest accumulated. Month. This seems like a word wrap. Did I actually? No, I didn't spell it all right.
Interest.
I came close.
Can you make the font see bigger?
I can. Let me get everything typed in, then I'm going to blow up the size so you can see it better. Balance at end of month. I am definitely going to make this font bigger because it's not usable as it is. Payment. New balance. The only running shoes used to fit my feet, actually. All right, we're going to do a little word wrap here. All right, beginning of month. Accumulated, balance at the end. Payment, new balance. Okay, let's see. Is that fun? Can we see that okay, everybody?
C.
Is that bueno?
C.
That cool? Okay, awesome. Okay, so we're starting with 600 bucks. We're gonna make all of this be money, so I'm gonna go ahead and format this all as dollars right now. Okay, interest. I know that the sheet has $6 interest. How did that $6 get calculated in that next cell?
606.
Right, but how did the $6 get calculated?
1% of 600.
Thank you, Ella. Absolutely perfect. Equals 0.01 times that previous balance. There's your $6. How's the balance at the end of the month calculated, dear friends?
616.
And how do we get that?
Add that shit. I love it. Like that.
Okay. Oh, and the payment, she actually gave it to us. I really am too. Okay. Oh, just FYI, I didn't realize this could be a thing with spreadsheets. It was freaking out my 243 students. If you're ever in a spreadsheet and you get a bunch of hashtags like that, you didn't do anything wrong. It just means that the font is too big. Exactly, Jessica. The font's too big and it can't display it for you. So you just have to make the cells bigger. We're going to make sure that, I know we didn't do a whole lot of spreadsheet work in here this term. Something else I'm going to change, I think. New balance. What goes here? And how do we get that? You got to take the balance at the end of the month, take off your payment. And then, what's cool about this is, we can probably just do that. And we can just put an equal sign down there and we'll pull it over. Cool, cool, cool? Now, I think we can just drag all the formulas we just put in from D, E, F, and G. Let's find out. How's that looking, friends? Does it match what y'all got? It's even rounded to the correct, I didn't even mean for that to happen, but it did. It's rounded to the correct number of decimals in cents. Yeah! And our balance is going down. Very good. Our balance is going down, which is why you're paying something off, right? Maggie, what you got?
The payment says 104.
Thank you. I forgot, Becky actually has this same payment all the way. I'm only going to copy 3 of those 4 formulas. You're right. Thank you, Maggie. Appreciate that. And Becky, yeah, I forgot that we don't want to copy. It's not smart enough to know to keep that value all the way down. Do you see what it did? It added $1 to it. I'm not sure why it did that, but that's cool. We'll copy the other ones. This is funny. This one didn't copy. Let's find out. That worked, didn't it? Ha! How's it looking? Pretty good? We're paying it down. We're paying it down. Paying it down. Ooh! And then we got 102.50. It is going to earn interest on that 102.50, yeah? So the balance at the end is going to be 103.52, which means we're just going to pay him that. We're not going to give him an extra penny, I guess. So I guess that's why Becky put that last little blank spot there. She wanted you to realize don't pay him 103.53, pay him 103.52. That way you're not giving him extra money, and that zeroes out your balance. Ah! Kind of fun. Cool, cool, cool. This is a situation for a spreadsheet, I think. Although, again, the way this is set up, it's formula-based, so we're going to... Now, the big thing is, how did we know the payment was going to be 103.52?
Because he stated he wanted to make, he paid off in 6 months.
Exactly.
And they already did the math for him.
And back here, exactly, the payment is given to you at the beginning, like, here's what you would have to pay in order to pay this down. So now the question is, how much did this kid actually pay? This is not in the warm-up, but it's got me thinking now. How much did this kid actually pay towards this loan?
103.53 times 70.
Never questioned my vision board.
Say that again, Christian.
Oh, I just said I've never questioned my vision board.
Oh shit, dude, let me, hang on. I can get the font bigger, I think. I don't know why I started it cells 3, I haven't done 2. Give me 1 second, see if I can, that's probably a little bit too. Is that okay, dude?
Yeah.
Do you see that better? Okay, so right here, that's how much he actually paid right there. He paid an extra $21.17 toward a $600 loan. Yeah. Cool. Go ahead, ask me that question right now. I shrink the face. I love that. Tell me what you think.
No, it's fine.
Are you sure?
Yeah, I figured it out.
Oh, okay. All right, you're a badass. I appreciate that. Okay. Cool. Now, the question I asked that Becky gave a very good answer for was, how do we know the payment was going to be 103.53? And the answer is, you can calculate what it needs to be. Do you remember the formula we played with last class? You don't have to have it memorized, but remember that it was kind of hellacious looking. It was the payment.
EMT.
You got it, Joey.
Something over, something.
Exactly. That was close enough, brother. something over, something. I'm going to hand you. This is not. I have an in-class homework for us to do too. But as I was, oh, John, I got you. As I was looking at Becky's materials, today's was pretty dense, and I thought rather than have it all be an in-class homework, I figured I'd start with just some notes-driven stuff. So this is just like notes that you'll just keep.
Love it.
And then the in-class will do it, have you turn it for points. That makes sense? Yeah. Again, I wish I had access to these files well before the class started, so I could have been working on this along the way, not just working on 243 and 98. But you know what? Whatever. You've been very gracious as I've tried to figure this out.
The math isn't mathing on the fourth line.
The math isn't mathing. Tell me
The
why.
balance at the end, I'm doing it on my calculator, and
Yeah.
it's 0.51, but it says 25.2 when I add the 3 level.
Are you rounding as you go, brother man?
No, I use the same numbers.
No, but are you, as you do, you're doing this, are you rounding as you go?
Yeah.
I guarantee that's what it is. Because this is not rounding.
Yeah, no, I mean, when I put in the answers that show, it gives
Uh-huh.
1 to
So Gage just said the math is not mathing, which does not surprise me at all, brother man. I appreciate that very much. The thing about spreadsheets that oh my God, here, hold on, paper. I love this. Chess, I'm good chess. So Gage, not to worry, brother man. Don't even sweat it. What's happening is if you're using kind of your phone calculator or whatever, and you're entering a cell, then going down, then entering a cell, then going down, you're rounding as you go.
Yeah.
Totally. And you know that when you round off, because if I was to increase the decimals on these, Gage,
Yeah.
give me 1 second here, brother. If I was to increase my decimals, you'll notice that these things are not exact, except for the payment. These things are not exact. The spreadsheet is carrying those inexact quantities as it goes.
I see.
You're not. And this is not a good or bad thing, it's just a thing. The spreadsheet's able to just let those things sit in the background and only show us the rounded values. But just because it's showing you the rounded values, it's not using those to do the math.
I see.
Is that fair, friend?
Yeah, no, it's just the math.
I know, it doesn't, you're off by a penny.
And it was a difference of 1 cent.
1 cent, exactly, which is exactly correct. This happens all the time with financial kind of stuff, because when you can do the math, it's the Office Space joke. If you've ever seen the movie Office Space, it's literally that joke. What happens to all those fractions of cents that are in the background? And the joke in Office Space was we're going to keep them, which I thought was hilarious. But in reality, you don't round off until you get to the end, and then round. Somebody asked me, who asked me this last week? Somebody asked me almost the exact same question in a different context. It was about round. Anyway, don't worry about it. It's all good. And this formula will take care of any.
So it kind of looks like the opposite of what we did the other.
Oh my God, Jessica.
Why? because it is, check this out, dear friend. This is Becky's words, because equal loan payments have to take into account a varying amount of interest. The formula to find the required payment looks complicated. There it is. I know, Jesse, I know. I already put her to sleep, it's okay. It's better than Sominex.
Hey, Sean,
Talk to me.
you have another one?
Of course, you have mine, brother. There you go.
I still have extra.
Now we got extra. I love this. But look at the language I put right below. Jessica, right below that horrific formula. Take it, Kendall. Not a great reason. It's just a savings plan formula solved for a different variable. All you're doing is you're turning the payment plan around and solving for the PMT as opposed to the, now this is interesting. She has changed one letter, which I actually don't mind this. The one letter she changed is she's not using B for balance anymore. She's using P for the loan principal. Okay, I can live with that if you can live with that. I guess that's maybe a financial term.
As long as I know what it means.
Yes.
My biggest issue, I think,
The terminology.
no, not necessarily, I mean, that is part of it, but, knowing which formula to do for which scenario.
So,
I just don't.
My dear friend, why I'm so excited about what we're doing on Wednesday, which is a combination of all of them in one big place, and you get to suss through them, and we get to talk about them and talk about which one we're using and why. Oh yeah, that's what I was thinking about. I'm like, I said I'm home with this, and then come back with sharp objects on Monday to stab me in the face, or we just do it in class together, and you can do sharp objects at home and not stab me in the face. You can stab me in the face once. It's okay. You've earned the right. All right, so Jessica, love that thought. We'll get to it, promise. So, and this one, if you think about all the formulas we've used so far, and it's three. There was the one-time deposit formula, which we did like 2 weeks ago. Put money in one time, let it sit for a long period of time, see what happens. That's one formula. Last week, we did the what happens if you constantly invest over a regular time period, each year, each month, each week. That, I call those annuities. That's not the correct term. I think it's called a savings plan. That's the formula you're thinking of from last week. This one is backwards in that you borrow the money in the beginning and then you pay it back until it's gone. So it's the inverse of last week. Last week we started with nothing and then built it up into a final amount. Here we're starting with the final amount and bringing it back to nothing because we want something that we can't afford outright right now. Talk to me.
Okay, so the one thing that's really screwing with my head is the APR, APY thing.
I know.
So is that, okay, you're aware?
I am aware of that.
Iron
Yeah,
out?
it's the idea of just because they say you're earning, we're going to hit this on Wednesday as well. It doesn't show up here.
Okay.
It doesn't show up here. It's the, man, and I'm not even sure,
The first question on the
I know,
homework
was calculate the APY. Was calculate the APY, which
there's
is
no numbers except for the one.
the interest rate.
But that was it.
That's all you need.
Okay, see,
That's all. If anybody couldn't do that first homework question, we'll at break, we'll do it. That way you get it done, you can turn it in. We'll do that first homework question together on the board.
Yeah.
It'll take a second. It'll take us a second. And there's really, I've noticed some of you have been Googling formulas online. Love that, by the way. You could totally do that. I love that you're doing that. You don't have to do that if you just start a certain thing. We'll do it at break.
Okay.
We'll do it. Stop me at 2 and we'll do it then.
Okay.
Is that cool? All right, all right. Other questions, or was that was a great question, Becky. I appreciate that one. And Jessica, I feel you.
I have the same question.
That's good. We'll do it at break. Like I said, we'll pull the screen up. We'll do it on the board. It'll take us minutes. Okay. So this is a pretty horrific payment plan formula. It's nasty, but it's not. It's actually not that bad. Do you want to practice? This isn't in the notes. Do you want to redo the warm up with this?
No.
Oh, okay. Okay. You don't have to. Okay. That's cool. Okay. We shan't then. All right, pull the screen up. I'm so excited it's fixed now.
I would if you did double credit this year.
All right. Okay. God, this place is, those are the flathead screws holding that thing in. Shit, man. Flathead screws. You have any idea how old those are? Flathead screw. Anybody ever used a flathead screw before? Shit. Oh, yeah, 2 of you. I love that. 3 of you. I love it. Okay, good. Let's do this bad boy. Or do you want to go straight to Desmos? Okay, now straight to Desmos. I can hear Becky already saying, nope. I want to do the formula once, at least once. let do last week, but she didn't mean it. Sorry about that, by the way. I got this great idea. That wasn't the idea I had. Sorry. All right, hang on. Get rid of all this. Okay. From the Washington Post about a year ago, an article where they're suggesting anyone who is carrying a credit card balance, here we go, perfect example of paying something down, might consider transferring all of that debt to a card with 0 interest. Aha! This is good. This is the question I asked earlier, remember? I said, if you borrow $600 from someone and you have to make 6 payments to pay it down, why isn't it just 6 payments of $100? And you responded, because interest. But if you can that was very aggressive. But if you can transfer that money over to a 0% interest card, you can get the best of both worlds. You still owe the money, but you don't have to pay it down with the interest. Okay, so suppose you have $5,805 in credit card debt, the average borrower's credit card balance. How did that compare? How did that compare to Oregon's? Shit, I can look this up. Because I made the 98 problem we did was based on the Oregon average of.
I'm curious.
At break, I'll look it up. I've got it saved in my folders. Anyway, $5,000 average balance, and moved it to a 0% card for 21 months. You could pay it off in less than 2 years, making roughly equal payments per month. Okay, let's stop right there. Jump over the blue line real quick. Let's check that claim. How much would they have to pay each month? Don't overthink this. Don't overthink this for this yellow question. If this person carrying this debt didn't have to pay any interest and wanted to pay it off in 21 months, how much would they have to pay a month?
It's the amount they owe divided by 21 months.
Yep.
Everybody hear that?
Yeah.
Exactly right. Thank you, Gage. I'm going to put the screen back on real quick because I can't do this stuff in my head. What if we can have, let me lower this down a little tiny bit, just to above the board. So that way I can put like Google up there. Still have the board. All right. So we're going to take the spreadsheet. We're going to take the amount they owe. All right, which is $5,805. Don't sign in. Skip. Yes, I got it. Just sum my information. Stop asking me questions. $5,805 divided by 21. Are you all getting? Oh God. $276.43. You can't see that because it's not quite there. Hang on. I wonder if I can tell Google.
43 cents?
I get 43 because it goes up because of the 8, yes?
Yes.
How about if I do, oh, what if I put a dollar sign in front of it? Will it give me a more sensible, nope. 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 Sorry. I was trying to get Google to round for us so we didn't have to, but it looks like we have to pay $276.43 a month. And then it's actually, that would be gone. The last payment would actually be a little bit less, wouldn't it?
Yeah.
Because we're rounding that up. Unless you're actually paying fractions of cents to somebody, which I doubt very much you're going to do. Right, exactly, Colette. So your last payment would be a few pennies less, I bet, due to rounding. Okay, good. Very good. Close so far, Meg? Okay, good stuff. Now, let's pop back up to the blue text now. That same payment at the average rate of 20.3%. You ever read the fine print on your credit card bill?
No.
Credit card rates are stupid. They lull you in with those 0% for a year or 0% for 18 months, and then in the fine print, once that time period's over, they expect you not to pay attention.
27%.
27% or something insane. So it's 20.3% for this one. Compounded monthly would take 27 months and force you to pay more than $5,805. So here's where we're going to use our formula. Is the payment about the same as the yellow one? So now the yellow one we just calculated would be about $276.43. I'm going to write that on the board real quick, okay? I'm going to write that on the board. So the 0%, my 0% payoff. Okay. 0%, 21 months.
$276.43, is that correct?
What is
Yes.
that 0%?
That's 0%. This is the yellow one that we just did. Because what I'm gonna do, Jessica, is we're gonna run this formula now
No interest.
on their, this is the no interest. Now we're gonna compare the blue situation to the yellow one. The blue situation carries interest. It carries, so let's do this. We're gonna figure out our payment now.
I think 0% after that.
Say that again.
But you have to.
Oh, no, 0% affects none. You don't need this equation if there's no interest.
Right.
This equation, now we're going to use the 20.3% compounded monthly, run that through this bad boy, and figure out what the payment is going to be on that. The claim in the Washington, whatever this is, the Washington Post, is that the payment for this situation should be similar to that one. Let's find out. All right, so now we're going to do 20.3% monthly compound. Christian, I want to ask you, because I remember last week I was writing too close to the top of the board. Is that okay? Can you see that okay? That's okay, thank you. You guys in the back see it okay? Okay, I remember I was writing too close to the top. I want to make sure that you can see this okay. Okay, now, payment. We're going to invert that formula from last week. Okay, remind me what the P is up top there.
The starting principal.
Thank you. That's how much that's the 5805, I think, right? 5805, we're paying that down, right? 5805, paying that down. 5805, thank you. Times APR over N, here comes, it's in the numerator of this fraction, which hopefully makes sense, because it was in the denominator of the other one. This should all be like clicking, like, okay, I'm getting this, I'm seeing this. So that's gonna be the 0.203, that's 20.3%, right, y'all? That was the most uninspired yes ever, Christian. I treasure it, thank you, sir. Divided by, we're compounding monthly, correct?
Yes.
Yes, and I think the idea is we're also paying this monthly. So the idea is your payment matches your compounds. So we're also be paying monthly, very good. Okay, that's the top of our fraction, yay. Woo. Now, remember how in the old formula it was something minus, talk to me, Becky.
So the 12, but it says take 27 months, so why isn't it 20?
The 27 is going to pop in with the years. It's how long the loan is for. Hold that thought here. I appreciate that very much. No, I love that. You hear what Becky just said? Wait a minute, hang on. Where's the 27 going to go in? Where's 27? 27 is not popped in yet. If you think back to last week, and I appreciate you drawing this connection back. Last week, we had a number of compounds per period, and we also had the length of time we were leaving it in savings.
Yes.
Same thing here. There's the number of times the interest compounds, but then there's also how long we're going to take to pay it down. That's where the 27 comes in. Is that fair? We're not quite there yet, Becky, but we're almost there, because it's going to show up in this next chunk. 1 minus. That makes perfect sense, because in the other one it was -1. I love this. The whole damn thing is inverted. Ha! Freaking awesome. Okay, let's keep going. All right. 1 plus APR over N, so this is a repeat of the top one. 0.203 over 12. And Becky, here comes yours. Here's where that 27 months comes in. We gotta be a little bit careful though, because Y is in years. So we gotta change 27 months to years.
24 months is 2 years.
12 months is 2 years. So it's
2.25.
2.5. Check my math on that. 2.25 years, 27 months. Check my math. Check me and Gage's math. 27 months, 2 years and 3 months, right? And 3 months is a quarter of a year. Yep, Jessica's got it right there. She's showing me. Pumped I can still see that. Wow. Yay! Okay, so now that's going to be that's going to be the only difference really in the formulas is that negative sign, because this is a payment versus an accumulation. Totally rad. Oh, minus 12 times 2.25. That's going to be up top of the numerator. And then we're done. Your job. Tell me what that equals. I'm going to do it too.
269.
Damn it!
Nico! Give it to me again, brother.
269.60799927.
That's kind of close to what they said, didn't it? It's good. Now, let's do this together. Let's do it together. Thank you, Nico. I appreciate that. Shall we do it in Desmos?
Yes.
I think this is
Yes,
kind of one of
please.
those. Yes, please. Listen to you. You were coming against Desmos 3 weeks ago. I love that. It makes me happy.
Well, I like it on the computer, I don't like it.
Oh, on your phone. Got it. Yeah, I probably don't
For
think on
some
my phone
reason
either.
it didn't.
Yeah. Sometimes apps just don't work well on phones. They work better on Oh, is that what that is?
Yeah.
As soon as one of those e-bikes come out, probably. Is it one of the control burn copiers? Oh, it's the life flight. They're doing the thing on the field. That's what it is. Is that okay? Can we? I just talk louder.
It's actually
Say that again. You can't be dropping shit like that and laughing without telling me what you're laughing about. Yeah, you can.
You said it. Yeah, you can.
I'll close it. If it gets too warm, we'll open up again.
That one's still.
You're approaching 2, so let's plug it into Desmos.
Yes, let's do this, damn it. Cut the shit, Sean. All right, here we go. You're approaching 2. Thank you, Becky. All right. Oh, I want to go scientific calculator. All right, here we go. All right, so I want to make a cheat looking for me again. So 5805. Let's make sure I put this. You can't see what I'm doing right now. Hang on. All right, here we go. 5805 times up top. I need a fraction. Oh no, I need that to be in a fraction. Excuse me. 5805 times, and then I need a fraction here as well. 0.203 over 12. There's my numerator, and it's pissed at me right now, as it should be, because I'm not done my expression yet. Whoa. Okay, bottom. Dallas isn't here to yell at me for not using the division sign. Oh, 2.5. Thank you. There we go. And there's Nico's 269.61. Yeah, I'd say keep that one. Keep this thing. If you're using Desmos, just keep it open. Oh, wait, I'll make it bigger. Hang on. If you want to use Desmos for the rest of the day, which I would. Oh God, that's terrible. That's all I can zoom is that or that. Huh. Anybody know Desmos? Can you zoom differently in Desmos? Huh, that's weird. Shit, sorry dude, just lied to you. I can't zoom any differently. When I zoom it in, the numbers stay the same size, but the keyboard gets bigger, which doesn't help us at all. Yeah, Control Plus, it doesn't, Control Plus does this. This is my trick for any, it just does that, which is so
Goes wide.
strange. It goes wide, yeah, and that little zoom pops in.
How do you get the stuff on the bottom again?
The stuff, tell me, ask that question again. Jessica, was that you?
Yeah, I can get like the.
These guys right here? We can do that real quick if you want. Want to do it again real quick from the top?
From the top.
Yeah, let's do it. So let's just put the whole bottom in again.
Well,
Let-
No, that's what I can't get to.
That's what I'm saying. Let's just put let's do the whole
No,
bottom.
I can't get that line.
Oh! I started with this button right here, Jessica.
I did that and it didn't work.
And then you got your fractions. Now you can put the pieces in.
So, you have to start it.
Does that kind of make sense?
You can use that. So you would hit this. I don't want hotkeys because I won't remember.
So yeah, to answer your question, as far as how do you get the fraction,
Thank you.
that little dude right there. Talk to Dominic.
When I try to do the -12 times 2.25, it doesn't like when you multiply.
Got you. Hang on. Let me back up. I did something I realized as I was typing that might be a little bit mean. So when you're at the end of that, you have to go to the exponent, right? Did you do Shift 6 to get up there?
Yeah.
Yep. Shift 6 gets you up there. And then you type -12. I'm assuming.
So, and then I want to multiply.
and then when you hit times 2.25, it boots you down.
Yeah.
So, and I apologize for this. I had a feeling it was going to do that. So what I did anybody notice what I put before that -12, Colette? I put parentheses. So when I kicked myself up to that line, Dominic, like you did, at shift 6, the next thing I did, it's so funny. It's one of those things I've been typing in single line display for 40 years of my life, and it's become just part of my background. So I apologize for doing that quickly, my friend. So once you're here, shift 6 kicks you up, then left parentheses. Now the computer is going to know everything you type is in the exponent. So -12 times 2.25 takes care of that. Is that fair?
Yes.
Thank you. And then you can press enter if you want to, but you can see the answer there already. Cool, cool?
Cool. Right.
All right. I'd say keep this one open. When we come back from break, we'll do more examples, and we can just keep editing the formula we have, which will be nice. We can just keep going in there and changing numbers on it, because otherwise you have to type that over and over again, which I mean, it's not the end of the world. Jessica, go ahead.
Why do you put the parentheses around 12?
Well, because as Dominic said, if you don't, you type the -12, and then when you try to type times 2.25, watch what happens. Check this out. It's that thing from Math 98 that I never say.
The 12 on the bottom of the
Oh! I didn't type those. That's weird.
I'm assuming that's what you meant.
Yeah, is that what you thought, Jessica?
Yeah, that's what I was asking.
I didn't type those. Shit. I didn't type those. I don't know how they showed up.
Okay.
I have no idea where that came from, dude. I didn't type them. Did anybody else see those show up? Shit, man. I have no idea. I got no good answer for it, Jessica. I don't know where they came from. I'm guessing maybe it was a built-in. Maybe I hit an enter or something and it put them in there because it was. I don't know.
And the parentheses on the top, you just.
That's crucial because if you don't, it kicks you out of the exponent.
When you do the times.
When you do the times 2.25, it kicks you down into the main line. Which is weird because it was not doing that last week with the other formula, was it? Remember last week with the other one? It wasn't. Oh, it was. It was doing that. Thank you, Jesse. Thank you. Appreciate that. Appreciate that. Thank you. Okay, it's consistent. That makes me happy. If it does the same thing consistently, then I'm happy. Shall we take 5? Let's take 5. Yes, Kendall's like, Jesus, you're 2 minutes late. And then let's talk about that APY.
And the homework question 1.
That's what I'm saying, the APY.
Oh, that-
Yeah, the APY. I got you, baby. I got you. Then we'll do APY. We'll come back, wrap up the last of these examples from the notes, and then we'll do the in-class homework, which is more of the same. We're going to do that homework question now, Jess. Yeah, as soon as everybody's square with this. Yeah, if you want, you can drop your warm-ups and everything into the offering seat. What's up, Dominic?
So it's asking to find you.
I have like tables, so.
Well, yes. That's to the end hour, right? We're actually going to do this one right now. Okay, so hang tight. No, hang tight. It's one of those ones, I'm realizing now that we haven't done it in 2 weeks much. Like I've bled it, or Becky I should say, bled it into all the homeworks here and there. But I think putting it on this homework, since we hadn't done it in a week, I think is confusing everybody. We'll do it real quick together. And we're going to do it the way we did it 2 weeks ago, which doesn't really use formulas, Dominic. It just runs. Yeah, we'll see in a second. There won't be any homework because it's the last day of class. We're going to use that project, which I can email it to you. So just email me and I'll get it to you. Yep. It is. I'm not going to get you homework on that day because that would be hard work. Oh, good. Yep, this is the scratch. Yep. Yeah. Anything. Yeah. Like the corrections you mean to get points back? Absolutely, dude. Absolutely. Yeah, absolutely. Yep. This looks. Yep. Okay, that's fine. So the payouts times the probabilities? Okay, got it.
So,
Oh, hang on, that should be, oh, it's not. This.
Interest rate is daily, right? So it'll calculate like.
Oh, gotcha, because it's positive. Sorry, it's been a while since I looked at this homework, so that's positive. So now you have to calculate what your cost to play. There we go. There we go. Got it. Got it. Drop that in the pot. That's perfect, Andy. Thank you. Yeah, it's been a while since I've seen that. That was back in the stuff I used to write.
It's a little off.
Damn, been a minute.
But it's super.
Okay, you badasses.
It was a baby.
Let's do this. Let's do this.
okay, let's.
Okay. How much?
Oh, I don't, are we all doing it?
We can all do it. You can hang up if you want. We can be like a comedy duo. It'll be great. Good cop, bad cop. You know. Yeah, pull a van, exactly. Give me the whole situation beginning, Becky. The whole thing from the beginning of the problem.
Okay, Max is 22 years old, planning to retire at age 67. He is investing in a mutual fund that pays 6.78% compounded monthly.
Okay.
That 6.78% is his APR.
Yep.
What is the APY on this?
Okay. So what might be confusing to you is I didn't give you a dollar amount,
Right.
but you don't need a dollar amount.
That freaked me out.
You could use any dollar amount you want, because whatever dollar amount you use is going to have the 6.78 apply. Watch this. Becky, pick a dollar amount for us to use.
500.
$500. Beautiful. Jessica, you pick a different amount. 100. So let's suppose you have $500 here and you have $100 here. We're going to do this two ways.
Okay.
Now, compounded monthly annual percentage yield is how much percent is actually earned each year. And just so you know, it's going to be more than 6.78% because of the multiple compounds. So let's leave it in for 1 year and see what happens.
Wait, I thought the Y was the year.
No, that's yield, annual percentage yield. Oh, yes, y in the formula is this lowercase y is here. So we're gonna leave it in for 1 year, not 45 years, 1 year, and see what he earns percentage-wise. Because that's what the APY is, how much he actually earns in a year.
Okay.
Okay, ready for this? Let's do this. 1 year and 1 year only, Matt. Okay, ready for this? 1 plus, okay, that's 0.0678. Divided by 12, because it's 12 compounded monthly, to the 12th power, because that is how many compounds happen in 1 year.
That's what it is.
That's okay, girl. We got you. Okay, you gave me 500, right?
Yeah.
You tell me what that equals. Jessica, you gave me 100, right?
Right.
You do the same thing.
Oh man, this interest is really complicated for me.
You do the same thing on yours, okay?
Right.
Hey, you're about to find out that Jessica's actually is going to be easier to calculate because she used the number with a 1 in the front of it,
Ah,
not a 5. It's okay, then. It's okay. It's all beautiful. It's all beautiful. It's all math. It's all beautiful. And one is even more beautiful. 1 is even more beautiful. Yeah, this was a discussion, you probably remember having it a couple weeks ago, where it doesn't matter what number you start with, because whatever dollar amount you start with will have the same amount of interest after 1 year, percentage-wise. Colette, what do you think? What do you think?
Does mutual fund like a minus one at the end of that?
Hold that question. It's a lovely question. Hold that thought, okay? I got you. I got you. Becky, what you got, my dear friend? Oh, you're still working on it. I got you.
I got fat fingers and this is a small little baby keyboard.
Small big keyboard, yeah.
Yeah, I need to use Demos.
All right, let's do it. Let's do it together. I'll put it up on the screen.
Okay, I got it.
You got it. All right, turn it off. Equals.
Oh, okay, hold on. Hold on just 1 second, just don't even,
I'm
just.
so excited.
Okay,
Okay.
534.97.
You are awesome. Thank you. Now, here's what I want you to do.
Okay.
That is clearly more than that, which means he earned his interest. But what I want you to do is I want you to figure out how much money did he earn over the $500?
Okay,
How much money? $34.97, right?
yeah.
How much interest is that divided by the 500? And that'll tell you the interest rate. Jessica, what did you get?
$106.99.
Now, Becky, you ready for this? This is why Jessica's was a wiser choice. I take that back. A simpler choice. She's gonna take the $106.99, $6.99 interest, right? She only has to divide by 100, which all that's gonna do is move this 2 places over. So she gets 6.99% interest. What did you get when you divided?
You started talking.
Wait, I started talking. See how she blamed me for that? That was awesome, by the way. I love that. I was doing math and then you started talking, Sean. And I love math.
Now, if I took the 100 off,
Hold that thought, because that comes into Colette's question that she is just asking. Hold that thought. Hold that thought. Hold that thought. Hold that thought.
So I would take the 534.97 divided by 500.
You can, and then you're going to have a 1.0699, I believe,
Yes.
which is the same percentage rate. You both earn roughly 7%, 6.99%.
So, on
Yes.
our homework, we should have just randomly picked a number. That's how anybody would have solved.
Or Colette has this, she's got a formula up her sleeve back there.
Yeah, well, I was looking it up because I wasn't here today.
Uh-huh. So you went and found another formula online, and yours was, I think, if I'm hearing you correct, Colette, you did this. Oh, there's an O in there.
what is it, 6.99%? Yes. Oh, I didn't do the minus.
What you're really doing, Colette, without realizing you're doing it, is you're using $1. But the formula doesn't use it. It doesn't matter what dollar amount you use, Becky. So if you don't use a dollar amount, you're focused only on the actual interest. So when you work the math on that right there, you get 1.0699, which is the same thing both of you got. And then the -1 at the end just takes the 100% back off, leaving you with what you actually earned in the account.
Okay.
Is that fair?
Yeah.
Okay. Did you like that? You like that formula, though, that -1 formula? Maybe I'll bring that back into the course.
Yeah.
Maybe I'll bring it into the course.
Yeah.
Maybe I'll put that on your project for Wednesday.
Yeah, I'm not good at ferreting out.
Ferreting that out. Yeah.
Yeah.
Maybe we'll use that. Yeah. Okay. That's good though. Yeah. When we did it in class, I simply asked, like, how can we figure this out? And somebody said, we'll just start with $1,000 or $100 or $10 or whatever. I forget whatever amount somebody said. And then we just chased it down. And like you said, we ferreted it out, Jessica. Well said. Well said. Which is totally fine. I mean, it's totally awesome. But it doesn't matter how you do it. You get about 7% APY. Is that cool?
Yeah.
All right. All right. Let's get back to our notes.
Wait.
Ah.
Don't you do it.
I know.
I made a sticker of you.
Oh no. Burn that.
No, it's so fun.
Run your ass out of town. That's how you.
When I send text messages.
Oh God.
You're like,
Oh sweet Jesus.
Oh my gosh.
People are gonna unfriend you. Steph already did. Okay, let's go back to the notes. People gonna unfriend you, Jessica. Say I didn't warn you.
I love it though.
I know. Okay, so what we just learned before break, before APY, was that nice little seat. I like this. So when you borrow money at an interest rate, clearly you're going to end up paying more than you borrow, which nobody questions that. That's the idea. It's the same reason it's like inverse savings, right? Which is why the formula is the inverse of the savings formula. So when you buy a large item, a refrigerator, a car, a house, unless you have that money in your pocket or in your bank account, you have to borrow the money from somebody else, and they're not out of the goodness of their heart going to give you the money. They're going to charge you an interest rate to pay it back to them over a long period of time. Fair enough? Okay, you badasses. Ah! Oh, that sounds so sad. That's you say things all the time that I don't hear because I'm not down here. I need to hear more often. Okay, let's flip over. Oh, we answered this question, didn't we? Did we answer this question? The little blue question? It should be on the first. Maybe we didn't answer that yet. No, we didn't. So we knew the payment using the formula. The payment was, shit, I erased it. What was the payment for the blue one back there?
$269.61.
$269.61. Thank you. And we're paying that for how many months?
27.
27 months, work this out. Thank you for remembering that number. I had forgotten. That's poor spacing. That question should be on the other side. Apologies. So we're paying $269.61, is that right? Or 71? Is it 71?
69.61.
61, thank you, Becky. For 27 months. The question on the backside there in blue, how much interest would you end up paying on that debt? Well, remember the original debt was $5,805, correct?
Yes.
We've paid more than that now, haven't we? How much in total have we paid?
269.61 times 27.
Say that again, Becky! I'll say it for you, Becky! 269.61 per month times 27 months. Joe, you got it?
Yep. That's $7,279.47.
7,000, say that one more time.
279.47.
My man, appreciate you. That's how much you actually end up paying. So that means how much interest have you paid on the original debt?
That minus the original.
Yeah, that's what you had to pay. The amount you were trying to pay down was only $5,805, correct?
Yes.
Thank you. See if Sean can do a long subtraction. Oh God. Sweet Jesus. Did I do that right?
Yes.
1474, 47? That's a lot of fours.